Kamera akcja. Ruszamy ponownie. Tak, w związku z tym zacznę od kolejnej palącej kwestii. Dlaczego Scala.js na etapie skalowym, oprócz tego, że pojawia się Scala? Scala.js jest takim bocznym projektem, mało kto go używa tak naprawdę. I skąd pomysł? Ponieważ tak naprawdę JavaScript jest aktualnie wszędzie. JavaScripta mamy na każdej stronie internetowej, ale to są truizmy. Mamy JavaScripta w telefonach komórkowych również. Ale możemy JavaScriptem programować aplikacje na systemy operacyjne desktopowe. Ostatnimi czasy możemy nawet automatyzować Macintosze, co już w ogóle jest czymś niezwykłym. JavaScript jest na IoT, a także można nim programować roboty. Także spokojnie możemy go upchnąć tak na komponent na GitHuba skalowego. Dlaczego JavaScript zrobił się tak popularny? Moim zdaniem wynika to z tego, że programiści od długiego czasu szukają jakiegoś świętego grala. Zwłaszcza dotyczy to programistów webowych, tych, którzy mają odrębne części klientu i backendu i chcą je w jakiś sposób połączyć, w sposób jak najwygodniejszy, jak najmniej intruzywny, bez przepisywania backendowej domeny w frontendową domenę za pomocą różnych fragmentów kodu. Stąd też JavaScript jest takim jednym stakiem, żeby wszystkim rządzić. Jest dostępny w każdej przeglądarce, a jak już pokazaliśmy, również w każdym urządzeniu, a równocześnie możemy go używać na serwerach w postaci Node'a i coraz więcej projektów, na przykład Artur.js, pozwala nam w wygodny sposób te dwa światy, klienta i serwera, za pomocą JavaScripta połączyć. Jednak jest problem z dużymi aplikacjami w JavaScriptie. Bardzo niewygodnie się na nich operuje. JavaScript w pewnym momencie zaczyna się rozłazić i staje się ciężką do zarządzania kupą kodu. W związku z tym wymyślono coś takiego jak języki transpilowane. Mamy takie gwiazdy jak Darta, jak na przykład CoffeeScripta, jak na przykład TypeScripta. I to są języki, które powstały po to, żeby nabudować na JavaScript funkcje, których programistom brakowało. Zwykle są to typy albo ukrycie pewnych problemów, jakie JavaScript ze sobą niesie, ze względu na dość kiepskie zaprojektowanie tego języka. Jednak jest też druga gałąź języków, które chcą nam pomóc w tego typu operacjach. Mamy również języki kompilowane do JavaScript, takie jak Google Web Toolkit, które pozwala nam użyć Java do tworzenia JavaScriptowego kodu. Do tworzenia JavaScriptowego kodu możemy na przykład użyć coś Rabiego, a tych projektów jest bardzo, bardzo dużo. Istnieją nawet takie jak CobbleScript czy Brainfuck.js. Akurat Brainfuck.js ma dość ciekawe zastosowanie, ponieważ pozwala na wykrycie dużej ilości plików w JavaScriptie i przejęcie przeglądarki użytkownika, ale to jest temat na inną prezentację. Warto o tym poczytać, jest kilka dość ciekawych zastosowań. Wszystkie parsery, wszystkie zabezpieczenia potrafią ominąć taki kod. Dobrze, ale wróćmy do głównego tematu. Scala.js. Scala.js jest projektem, który gdzieś w okolicach marca został ogłoszony jako gotowy do produkcyjnego użycia. A skoro jest gotowy do produkcyjnego użycia wśród twórców, można zacząć wreszcie próbować się nim bawić w użyciu niekomercyjnym. Kolejnym powodem, dla którego warto choćby rzucić okiem na to, jest to, że tak naprawdę...
Bardzo się przepraszam, mógłbyś się przełączyć na angielski, bo się
Okay, no problem. Okay, functional approach is also very popular in JavaScript world. I will start with underscore, which I think is in every one project in JavaScript right now, or is or will be, or was, because there are many people who don't use it anymore, but everybody tried. Immutable.js from Facebook, which bring immutable collection to the JavaScript. We have React.js, which also gain many abilities of functional approach. And additionally, functional reactive programming is a paradigm which brings many developers and many different new libraries. For example, Bacon.js or Elixir.js. So we can try with Scala. So I will start with the code to warm you up. We have a simple piece of code. It's a standard Scala class, and whenever we extend JS app object, we can compile it to the JavaScript. And we can do that. Whenever we do that, our business logic will change something like that. Looks scary, right? But it's not all. I have a compiler right here. It's a Scala.js Fiddle, a quite nice tool to check how Scala.js behaves. And as you see, this code will just print 1,000 numbers. Like you see, it's dark in the right corner. Do you want to see how whole code looks like? Maybe not, but I will show you otherwise. Wait a moment. Ta-da. That's not all. Okay, I will go to the bottom. Maybe not. But this is a code we will acquire when we try to compile our Scala.js to the just.js. And why is that? Because Scala.js, with difference, for example, CoffeeScript or TypeScript, don't compile just to JavaScript. They are bringing all necessary Scala runtime environment to the JavaScript code. What we can see on this one picture. And this code, for the simple hello world example in JavaScript, takes about 1 megabyte. So we don't want to see something like that in our environment, especially in our browsers, especially for the JavaScript. But people from the Scala.js team bring way to optimize it. You can run a Clojure compiler, and Clojure compiler make for us a simpler, smaller block of code, still big. Nice for the hello world. Thank you, Scala.js. But why this is not, this piece of code takes about 100 kilobytes. Still big amount, especially for such a block, but this is nearly all you will need to run majority of your Scala code. It's not Scala up with bigger enlargement of your business logic. So this is point worth to say, and I will be back in our presentation. As you see, it's not that nice. We can cope with that with some tricks. I will show them later. Okay, but we'll be back in the Scala.js code. To run our sample, we need to put a line like that in our code, because in the comparison to the normal JavaScript, the Scala.js execute itself later. They don't have execution line by line. Everything must be executed by calling some method. In our example, it's a main method of the Scala.js example. The first element is our package. In this example, it was just our example package. Scala.js example, name of the object, and method main.js. That's all. So it's time to try second example. This code was that small just because people from Scala.js team throw away everything they don't need. So if you are creating something like a library, it will not be possible with just code like I showed before, because everything which is not explicitly used in the source code will be thrown away. For example, a part of the main method export and method export to will not be available in our source code. To achieve show compiler that we don't want to throw it, we need to use JS export annotation. This, after annotating these methods with such annotation, we can use them explicit in the JavaScript code. Additionally, we have one more handy annotation because, for example, all jQuery objects use val in some way. And val is forbidden word in Scala. So to be able to name our method val, we can use JS name annotation. And it can be run. What I showed you before is a general problem with transpilers. A code is big, and whenever we have big code in a JavaScript, our app runs very slowly. So we need to rely on our SBT plugin. SBT plugin has a few different tasks. This is a specific plugin for the Scala.js. There's compile, package, fast optimization, full optimization, run test. The first one is compile. I will say a few words how it's working in the belly of the beast. A compile task make two different types of types. The first one is a standard Scala class. Second one is similar to the Android because people in the Scala.js team decided that they won't be able to make optimization without bringing intermediate form to their language. And Scala.js use language like that. It's a simplified ASIC syntax tree of Scala, cut down to just the elements that can be usable in the JavaScript world. For example, annotations are thrown, implicit are thrown, many different elements are thrown too. A second element is package. Package makes for us one single jar with both class files and our intermediate form. There's a quirk. You are not able to run this jar. This jar is necessary for the additional step. And this additional step is creating our JavaScript code. It's two different methods. Fast.js is way to create the first part, the first big code I showed you, the one that is not shrink down, uglified, and it's quite faster. So it's used in the development to show, we'll see how code looks like. And a second task is full.js. It's a closure compiler. It uses closure compiler to shrink our source down. It's a full optimization to make code as small as possible. This code, which I showed you before, is 100 kilobytes with the non-given version and about 22 kilobytes with the given version. So it's not that big, it just looks ugly. The fourth task, interesting one, is run. Because every one class you have in your run class object, you have in the JS, Scala.js, you can run from the command line. You just need a mind method in it. And whenever you do it, your code is run on Rhino, so you have access to it from the every JVM environment today. But it's quite slow. If you have Node.js or the best Phantom.js, our environment will find it and run a code using one of them. And last one is test. A test for the Scala.js code can be run like a just normal Scala test. They need a special library. I will talk about it in a moment. But our code looked really, really bad. So there is hard to debug something like that. And people from the Scala.js know that. So our SBT plugin additionally makes for the every compilation, both fast and full, source map. And the source map are available in the folder of our JS files. Do you know what source map is? No. So if we have no, source map is because many languages started to compile stuff to the JavaScript, like we said, TypeScript, CoffeeScript, and many different, we needed something to debug it in the environment, standard browser environment. For example, even for the language which looks definitely better than the Scala.js, we need something which would help us. I have quite experience with the CoffeeScript, and even if this code is just normal JavaScript, which quite looks okay, it's hard to debug both your runtime environment source and your source code together if you have an error. Especially you have no time to repeat that error, repair that error. So standard for source map parent. And this is a special text file with a map extension. And whenever it is available, browser use it to map source code to the JS code. How it looks like in the Scala.js. We have our compiled example JS fast application. It's just application that do if works command. As you see. And wait a moment. We have this extension. We can debug. Wait a moment. We have our Scala.js code accessible from the, for example, from DevTools, and we can make our breakpoints inside it. But it's not that we can do all the evaluation line by line. As you see, it works, line happens, and we still are in the debugger. Won't be evaluated in the debugger. So we have code like that, and we can debug it. But to don't make it too easy for the developers, for example, CoffeeScript has accessibility to be debugged line by line in the browser environment. There is no Scala parser in the front. So whenever we want to access from our browser to access to our code, we need to use very strange, very not readable comment. Oh, wait a moment, here. As you see, our example package is accessible in the window object, and then we have all our methods from our code. This example, will be a square method from the Scala. Here, square int x multiplied by x. Not exactly square, but it's called like that. And we can run it from the browser environment. So this method is accessible to our Java.js example annotation. If we would like to access specific Scala code, we would need to get to the special G object inside a global scope of the closure. It's not that handy. You can't run all the methods of the Scala. You can only run the exported one. If you want to access the whole environment runtime, you will acquire with your big blob code. That's not possible. In an example, if that's possible in an easy way, you need to dig through the closures. It will be there and can be run, but just from the debugger. It's not that useful. So we say about that. Time to example 3. Because why we could even use a Scala.js in our environment? Because Scala is type-safe. And surprise, our code in the very basic form is not type-safe. Because it's just written an XR object with response text inside. Not that, it's not what we are looking for. The code is not strongly typed. But people from the Scala environment make a method autofire. It's possible now to explicit map Ajax expression to the given type with an adjuster and name of the method API. And then, in the contrast to the standard XR object, which is available in the Ajax, it will be explicit type of the object. There is many different language libraries accessible for Scala. We have the method for Scala.js, we have method for DOMs, we have method to creating HTML easily. Method to the test, because standard test method for the Scala will not work with the Scala.js. They are specially written ones. We have JSON parsers. What I can prefer from all of this stack, this is this one JSON parser. It takes a JSON string and parse it to the really handy objects. So I can suggest to try it. We have boopycle, to do the same but just with a binary format. We have auto-var, which I was talking about. And we have, for example, workbench. Workbench is interesting because it brings auto-loading of the environment to our Scala.js compiled code. After each compilation, browser is rerun, and we can see changes in our code on the runtime. What queries Scala.js has for in the difference to the standard Scala? Float. Float behaves like in the JS. Float in the JS are broken. So the whole broken environment is brought to the Scala, unfortunately. We don't have option to check, to try to catch the exceptions. Exceptions are thrown away because people from the Scala.js decide that they will be too expensive to solve in the simulated Scala.js environment in the browser. So they will just throw exceptions. Regular expressions are different. They are regular expressions from the JS, no regular expressions from the Java. And they are small difference between them. There is also the thing you need to take a look. And reflections are not supported in any way, JavaScript. So that's understandable. Conclusion. It wasn't that bad as I supposed before. We have few things that are quite handy. The code is quite nice in the bigger project. I didn't show that because there is no place for that. But code looks quite nice and framework works. The intermediate code, the whole pipeline is usable. The code is dirty, but it's not a problem to the time as something broke. So not for production environment form. But there are people who are using compiled languages with the success in the production. So it wasn't that bad as I supposed before, because my plan was to conclude it with a form that ECMAScript in the future don't use anything other. Scala.js wasn't that bad. But what was the stretch? A strongly typed. As we said, what I really hate in JavaScript is the fact that every one of the problems happens on the production when the method is called. So having a compiled code in the JavaScript is quite nice. That's why that many different languages transpile to it. We have ID autocompletion. Our ID autocompletion just works just the way that it works in the standard Scala, in the both Scala either from the Eclipse, like IntelliJ ones. It's better known languages for Scala test. I had a problem. I have a situation. My first job, that one person needs to make some patching in the JavaScript, which was connected to the drawing the canvas, making graphs. It was a standard Java dev. He has no big knowledge about the JavaScript apart of that you can get an idea on the side. And what he produced was really, really bad. Because it was lagging, it has many really small amount of keyframes, and when he write nearly the same code to GVT, it started to work okay, without lags, without broken keyframes. So sometimes it's good to know a tool you know, good to use the tool you know, because without bigger knowledge about the language, you can make something that don't work that nice. And we have our single language code base. We can use the same object in the client, the same object on the server. We can communicate them like in the way similar to the RPC. So this is okay. Weakness. The weakness is quite big. We have big result files. We have seen that. You have seen that. They are really, really big, and especially for the hello world examples, whole Scala runtime in the JavaScript will take a big of the much of the place. And debugging is much, much harder. People say that there is a way that if you use a remote JavaScript debugging, you can do the same with the IDE. In theory, I have many problems with that approach. The IntelliJ broke connections, the socket was left, and when I was debugging my code, a connection was often dropped. So I don't suggest that way. It's not part of the JS ecosystem. That's the reason why I dropped CoffeeScript. I really love CoffeeScript for the writing JavaScript code, but then Node happens and ECMAScript 6 happens. And all the tooling was not suitable to the CoffeeScript that much. They were usable because CoffeeScript is quite easy to integrate to them, but it was often and nearly always brute force. Just don't taking a good way of the tools and don't using them the way that they were done. There is not lack of support for many libraries. For example, Akka, I heard that Akka is supported right now, just not official. And for example, JUice. And last but not least, the performance payoff is quite big. Because when we have a much more amount of the code in JavaScript, they need to be parsed. And JavaScript parsing is quite slow. So this code, it works quite fast because it's just a simple example for the powerful machine, but not something which I wouldn't use anything that really needs performance in the background. What chances Scala.js brings? It can be our holy grail because we have both the same code in the backend and on the server, on the client. And that works quite nice in that way because we can share nearly all domain objects or even our implemented algorithms. Our code base is more scalable than in the JavaScript because it's Scala. Scala is better suitable for the big projects. There are chances that more libraries will be supported in the future. For now, we have a binding to the jQuery, to the React.js, to the Angular.js, to the many different projects, but they need specific bindings. So they need to be someone who wants to rewrite them to work with Scala.js. We get big amount of the Scala environment, but everything from the JavaScript needs to be specially reintroduced in Scala.js. And creative promise that they are working for the better performance. They are made daily intermediate format, especially for that, to be able to experiment and to work on making Scala.js better and better. And what are the the worst tricks? There is marginal amount of developers who will use Scala.js. If there will be a problem, we don't have support from anybody. And if creators will lose the interest in, project is dead. And the worst one, is abstraction. And every abstraction will leak. And whenever your abstraction leaks, you are only in the end with your machine-generated code and no idea how to solve it. A problem you have because something is wrong in your specific case. On the end of the presentation, I left a few links. There is a quite long and quite interesting hands-on from the Scala.js from the guy who made a majority of these libraries you have seen on one of the slides. It's interesting introduced for the beginners. There is Scala.js Fiddle. It's the one I have used during a presentation that can let you run Scala.js code in the fly. There is a Scala.js SPA tutorial, which also is a good example of how you can use Scala.js in a single-page application. And if someone would want to play with Scala.js, there is also activator for that. And now, thank you very much. Do you have any questions? Yeah.
Okay, so why would you want to run account?
There's no reason to do that. That's why Scala.js is not using Akka, but there are people who want to do that. We need to ask them.
Why?
I don't know.
Okay.
That was also my question. Yep.
So, I understand that before I got that it's not there yet, but it's just some sort of experiment. It's not going to be in production at some point of time. It's just an experience from a guy who would like to use Scala in the browser. That's also just an experiment.
Yeah, definitely. That's what I said. It's better than I expected, because I expected that it would be totally, I would say, shitty. But it was working. It was working for fine. It was of the quite interesting things happened in the background, in the development pipeline, compilation pipeline, and I wasn't that, wasn't left that bad impression. I super well.
We have a pretty big community actually, so while yeah, it's not really supported by any company, and it seems to have a big enough community to stay alive.
So it's just a work in progress for now.
Yeah, so they claim it's ready for production, but I don't know.
I would say TypeScript should take on Dave's blog that it's ready for production. So
actually, I spoke with the creator of the Scala exchange, and he told me that he was talking with TypeScript for possible deployment for him. So
we are passing the voice.
it might be serious in the near future.
It might come in production somewhere, but not the
Well, I wouldn't believe it that it's that kind. It's now.
Do you have any other questions? If not, thank you very much. I will pass the voice to